aeronautics is thriving and continues to push us forward on the cutting edge of aviation. Innovation is at the core of all of NASA's missions, and for decades we've delivered new technologies to the public and to industry. You may not know it, but every time you fly, you're surrounded by technologies that NASA has helped develop over decades that improve your experience and also make your flight safer and more sustainable. Today, we are very excited to be discussing a major new NASA commitment to reducing carbon emissions in the air transportation system. Aviation is one of the most difficult industries to decarbonize, and we're very excited to be working on the hardest problems. We're also hoping that the technology we're working on is something that you will be seeing across industry and at airports in the 2030s. I don't know about you, but I fly a lot, and in addition to the many improvements in aircraft and air traffic control efficiency and safety that NASA's work has provided to make your trips easier and safer and better every time you fly, I'm still very concerned about the carbon footprint of global air travel. The aviation sector is a giant in the global economy, and we have to take that seriously. We rely on it for very many things, not only as an engine of commerce, but also as an engine of connection of human beings around the world. But we know we can lower the emissions that all those flights produce, especially on the workhorse planes, which most of us usually fly. This is a key part of what we do at NASA, partnering with industry to innovate and take concepts to reality that can spread throughout a sector for the benefit of all. At NASA, we're committed to learning about our planet's climate, and by mitigating climate change, using our resources across a broad spectrum, from satellites to instruments aboard the International Space Station to new technologies in aviation and other areas. NASA provides vital climate data freely to all, data that helps our leaders pursue climate-resilient strategies and decision-making, and helps citizen scientists and others stay informed. We work to develop technologies that will move us towards a sustainable future, here on Earth and as we explore space. Today, we make a big leap in green aviation. I'll let Administrator Nelson and others break the news and talk specifics, but I have to tell you, as a pilot and a test pilot, I am very excited by today's announcement. NASA's research directly contributes to the long-term sustainability of aviation, and by advancing the development of green technologies, we're revolutionizing air transportation once again. With that, I'd like to introduce NASA Administrator Bill Nelson.
Thanks, Pam. Most of you all think of NASA as a space agency, as an aviation agency. It's also a climate agency. Not only all the assets that we have up there in space that are measuring what is going on with our planet, and will increasingly do so over the next decade, but also because we are constantly trying to figure out how to reduce our carbon footprint here as terrestrial beings on the surface of planet Earth. So today is an announcement about aviation and climate and technology, and Pam has introduced the fact that when you fly in any kind of aircraft, you are surrounded by NASA technology. We have made aviation more sustainable and dependable. It's in our DNA. Now, during the 70s and the 80s, NASA research resulted in a new type of wing, the upturned tips of wings called winglets. And those are on most commercial airliners today, increasing the distance that you can fly and saving billions of dollars of fuel. And today we're improving takeoff and landing taxi technology to save fuel, cut delays, and to get you to your destination sooner and cheaper. And we did a multi-year project at the Charlotte airport. It's now in 20 airports around the country, so that when you pull back from the gate, you go continuously without that stop-start that burns so much fuel, and by the way, burns you up in impatience to finally get on your flight. And so smoothly down to the end of the taxiway and on and take off. We're working to develop new next-generation aircraft and engines that would make commercial airliners as much as 30% more efficient. And we're investing in supersonic flight over land without a sonic boom. We're going to test fly that X-59 this year. And if we can accomplish that, people across the world are going to be able to fly over populated areas supersonic to get to their destinations faster. And we're leading the development of electric propulsion powered aircraft. We're going to fly the X-57 this year. Quieter, more efficient, and environmentally friendly than today's commuter planes. And so NASA is at the cutting edge of technology when it comes to flight. That's part of our charter. That leads us now why we are gathered here today, to announce the next big development in NASA aeronautics and the commercial aviation industry. NASA has selected Boeing as our partner in designing, building, and flying a brand new large-scale experimental airplane called the Sustainable Flight Demonstrator. And Boeing's concept is a transonic, truss-braced wing, single-aisle aircraft, which is scheduled to fly in 2028. This aircraft, which will serve approximately 50% of the commercial market, which is short to medium haul, single aisle aircraft. But we're going to reduce as much as 30% the fuel consumption with better engines. And look at this wing, longer and thinner. And it's so long and thin, it has to have a brace. But you can actually get lift on this brace as well as the wing, the old concept of the old biplanes. That is a revolutionary design. And this is going to be flying in 2028. It's our plan to demonstrate this extra long, thin wing stabilized by the braces that will make commercial airliners much more fuel efficient by creating less drag. And in addition to the design, the Sustainable Flight Demonstrator will integrate multiple other related green technologies. This configuration will save fuel, and as we know, saving fuel is not only good for the planet, it means less expensive tickets for passengers. Flying in the U.S., you're likely to board a single-aisle aircraft like the size, think of a 737. They are the workhorses of most of the fleets. They remain the most in-demand design and are critical to retaining American competitiveness in manufacturing. And Boeing estimates that the demand for the single-aisle aircraft will increase by 40,000 planes between 2035 and 2050. And despite advancements these single-aisle aircraft are also responsible for about half of the emissions today in the commercial aviation sector. And that's exactly why NASA chose Boeing for this project. Boeing's proposed design could make a significant contribution toward our goal of improving fuel efficiency, as I said, by as much as 30%. And we and they have a plan to make that a reality. In just a few years, this project aims to revolutionize the kind of aircraft that the public uses most frequently when they take to the skies, and it's going to be able to help meet President Biden's goal to achieve net zero aviation emissions by 2050. So congratulations to the team at NASA, congratulations to Boeing on this very exciting new project.
Thank you, Senator Nelson. This is really, I want to thank everybody for being here, and this is just such an exciting time. For someone who's spent his entire career, my career, in aviation and aeronautics, this really is a seminal moment, I believe, for the future of aviation. So this is just an exciting, not just for me, but for all of NASA, for the White House, our fellow agencies, our partners, the innovators who are all working towards a sustainable aviation future. This is a really critical moment. Our partnership with the Boeing company is not only transformative, but it's a smart investment in a critical asset, the air transportation system that moves millions of people and tons of cargo every year. It's proved vital to our response to the global COVID pandemic. I think everybody can relate to the fact that, during the pandemic, more deliveries were made. Think about the distribution of vaccines. I mean, all of that, if we didn't have an air transportation system, those things would not have been possible in the way they were. So this is a vital asset to the nation and to the globe. And looking forward, looking to the future, creating those next technologies, getting them into the system is absolutely vital. So the Sustainable Flight Demonstrator project is the largest, most ambitious effort under NASA's Sustainable Flight National Partnership. That partnership is a portfolio of technology investments in 3 areas to make aviation more sustainable: aircraft technologies, flight operations and infrastructure, and sustainable aviation fuels. The Sustainable Flight Demonstrator, or SFD, is the culmination of work with industry over many years to explore advanced aircraft technologies to reduce fuel burn, emissions, and noise. We've been working at this, technologies like this for well over, 15 years. In fact, NASA has been, part of aviation from the beginning, and as Pam said, many of the technologies, if you get onto an airplane, NASA technologies are all around you. So the work we've done over the last couple of decades, specifically in, hey, what's the next generation? What's beyond the kind of airplane we're flying today, has led to this moment. And that's why, to me, it's such a seminal moment. So we have been advancing and exploring these advanced technologies, and we've been testing them in simulations in NASA wind tunnels, and we're now moving to that next stage, demonstrating this promising technology in flight. NASA is committing $425 million for this SFD through a funded Space Act agreement. Boeing and its industry partners will contribute the remaining costs, currently estimated at $725 million. For the next 7 years, the Sustainable Flight Demonstrator project has 3 goals. First, develop and flight test an advanced airframe configuration and technologies that together dramatically reduce aircraft use and CO2 emissions. As Administrator Nelson mentioned, 30% more efficient. Second, obtain ground and flight data that NASA and the industry team will use to validate the transonic thrust-based wing configuration and its technologies. Flight demonstration is absolutely critical. And 3, most importantly, is inform industry decisions about the design and manufacture of next-generation aircraft that will enter service in the 2030s to meet the environmental goals articulated in the U.S. Aviation Climate Action Plan, basically to get to net zero emissions by mid-century. We chose to use a funded Space Act agreement because this arrangement allows NASA to harness the knowledge and innovation of an industry partner while demonstrating advanced technologies that can inform industry decisions about future aircraft. Boeing and their industry partners are bringing their resources and expertise to this partnership. But NASA as well will be providing technical expertise and facility testing support in addition to providing fixed payments as milestones are achieved. This really is, in my view, a Team USA approach to a really important project. NASA engineers, technicians, and other specialists will participate with Boeing and its partners throughout the project lifecycle. NASA ground testing support will include some of the high-speed wind tunnel testing, structural testing, some of the wing components, piloted simulation, and acoustic testing. Flight test of the SFD is also expected to utilize NASA facilities at the Armstrong Flight Research Center in California. NASA selected Boeing for the SFD based on their design concept and expected performance benefits, their plan for addressing key technology gaps, and their plans for technology demonstration and potential for commercialization. The SFD's first flight is targeted for 2028, just 5 years from now. This is a true partnership. None of us could do this alone. So I want to acknowledge the team of NASA aeronautic innovators led by Project Manager Brent Colby on stage here with me today, who have literally worked for months tirelessly from the acquisition planning through the request for proposals, reviews through selection to make this announcement possible today. And now I want to call to the stage my colleague, the Boeing Chief Technology Officer, Todd Citron, to say a few words. Todd?
Well, thank you so much. It's just such an honor to be here representing Boeing on an occasion that I'm sure many of us will remember for years to come. It's really true that we're going to be making history together, and we couldn't be more proud and excited to do so. I'd like to thank Senator Nelson, Deputy Administrator Melroy, Associate Administrator Pierce, and the entire NASA Aeronautics team for their work to make this milestone a reality. This agreement reflects a partnership more than a decade in the making, as was mentioned, to study the transonic truss brace wing configuration, or TTBW. It began with early conceptual studies and other phases of sustainable aviation research. And through wind tunnel testing and digital modeling, we've been advancing the design to meet the requirements that this moment in aviation history demands. The technologies demonstrated and tested as part of the Sustainable Flight Demonstrator program, or SFD, could shape future generations of single-aisle airplanes with breakthrough aerodynamics, fuel efficiency gains, and drastically lower emissions. This comes as the entire civil aviation industry is moving towards a net zero carbon emissions future. Through NASA's agreement with Boeing and with the support of our industry partners, we'll be leading the development and flight testing of a full-scale SFD demonstrator airplane. When the demonstrator takes to the skies in 2028, it'll do so on ultra-thin wings, as the administrator referred to, braced by trusses and with a larger span, resulting in higher aerodynamic efficiency. This high wing configuration will also free up underwing space for advanced propulsion systems. And what this means at the bottom line is that a single-aisle airplane with a TTBW configuration could see fuel consumption and emissions reductions up to 30% relative to today's most efficient single-aisle airplanes. These gains derive from the TTBW system, as well as expected improvements in propulsion systems, materials, and system architecture. Now, in addition to the funding and very valuable expertise from NASA, Boeing and our industry team have also committed significant resources in the support of sustainable flight, not only over the last decade, but as we move forward to the SFD program. For Boeing, this ties back to our broader sustainability vision, an approach we call everything for zero. It's anchored around 4 strategies: fleet renewal, operational efficiency, renewable energy transition, and advanced technologies. TTBW is one of those technologies, and it has the potential to be transformative and truly make history. Today's occasion shows the importance of purposeful partnerships that can play in creating value as we work together towards the industry's commitment of net zero carbon emissions by 2050 and the environmental goals outlined in the White House's U.S. Aviation Climate Action Plan. As I reflect on this moment in time, this moment in history, we find ourselves at a critical junction. We're facing climate changes and economic imperatives that require bold action. And with the support of NASA and our partners, we're optimistic that we're ready to meet the moment. We're looking forward to making the journey together and appreciate it. Thank you very much.
everyone. I'm NASA Press Secretary Jackie McGinnis, and our speakers, Administrator Nelson, Deputy Administrator Melroy, Bob Pierce, our Associate Administrator for the Aeronautics Mission Directorate, and Boeing's Chief Technology Officer, Todd Citron, as well as Brent Cobley, our Sustainable Flight Demonstrator Project Manager, will now take your questions. We'll hear from folks in the room and over the phones. If you're on the phones, you can press *1 to get into the queue. If you're in the room, you should go to one of the mics on the side. Our first question is from Micah Maidenberg with the Wall Street Journal, here in the room.
Thanks, Jackie. Good morning, everybody. Maybe for Administrator Nelson, or could you just talk a little bit more about why NASA is backing this? You know, when the private sector doesn't see a business case or a commercial imperative to push for such designs, you know, for many years out.
Let me restate the question. Why do this? Why have a competition to make a design? Why use a public-private partnership in order to come up with a new airplane? Well, first of all, do you want to get more efficient? Do you want to burn less fuel? You want to be more friendly to our planet and climate? Do you want to have technology continue to advance? One of the things that was said here, that high wing on the fuselage allows some kind of new technologies with regard to the engines. And there'll be new technologies of considerable savings with regard to the engines, as well as the aerodynamics and the wing. Notice this wing. It's so much longer and it's thinner, and therefore it has to be braced. And as a result, you've got all kinds of new aerodynamics there. So if the question is, why not just let industry develop this? Look at the new model of a public-private partnership in almost everything that NASA does. We're doing it in low Earth orbit, commercial crew, commercial cargo to the International Space Station. Eventually, after the life of the station in 2030, we're going to replace it with commercial space stations. Look what we're doing beyond low Earth orbit. We're going to the moon. We're going to, with a government rocket and spacecraft, we're going to have a polar elliptical orbit of the moon, and then the crew is going to transfer into a private lander. The first competitor that won there is SpaceX. It'll be a SpaceX lander. This is going on and on. It's in everything NASA does, including the climate and obviously aviation. And one final thing that I will say. This is as a result of competition. We had several excellent proposals. Bob can tell you about how the selection was Boeing as being by far the best. But what does this mean at the end of the day? It means a better lifestyle and also more jobs and less cost for passengers to travel on commercial airliners. I hope that's sufficient reason for this announcement today.
And if I could just add, I mean, absolutely everything Administrator Nelson said, you know, is really spot on. But the thing I would add is that this is an experimental aircraft. This is not a commercial development of an aircraft that you know, passengers are going to fly in today. And the reason we need to do that is because this is high-risk technology. And together, by partnering between NASA and industry together, we can go further. We can stretch further and take on higher risks than industry can do on their own. So it's not that, I mean, when it comes to making a commercial development, Boeing or whoever needs to do that on their own. That is not something that we would put anything into. It's only because this vehicle is a path to validating technology. That's why we're doing this. We're trying to validate technology. We're not trying to build a commercial product here. It just because it's large and and it's an aircraft doesn't, you know, it really is just a path to that technology validation.
And if I could just add, sustainability is a central part of Boeing's mission. And this partnership, I think, is a fantastic way to advance technology for the good of all of us, for the reasons that the Senator talked about. We're investing together with NASA substantial resources, but we also make direct investments as well. And I think we've got to exploit all of the avenues to advance sustainability because it's critical to all of us.
Thanks very much.
Thank you. We'll take our next question from the phones. John Hemmerdinger with Flight Global.
Hi, everyone. Thank you so much for doing this. I did want to ask a little bit more about the timeline. You're saying 2028, which I think is delayed a few years from the previous plan, and talking about bringing this to a commercial aircraft in the 2030s. Generally, these programs need a number of years to get going by the developers, maybe 7 years or more. So can you tell me about realistically how likely we are to see this in the 2030s? Thank you.
That'd be good. I'll let NASA comment in terms of the timeline. But you know, as you bring up, it does take a while to mature the technology to the point that it's ready for insertion on a commercial product. And that's why we want to be exploring this now, in order to have the potential, depending on the results of this effort, to bring this to a commercial product in the future.
And from the perspective of the 2028 first flight, it's, you know, simply the planning process, the budgeting process, and so forth. There's a lot that goes into this. You know, like we said, I mean, this is over a decade in a lot of really challenging ground tests, you know, simulation and so forth to advance the concept to the point where we're confident that the next step is flight. And then it just takes some time to do that kind of development. So we probably had earlier dates, you know, when we were in sort of pre-project planning and so forth. But, you know, as you do more detailed planning, things get a bit more realistic, and you lay out what you believe is the most realistic timeline. And we think that the 2028 first flight is the most realistic time frame for getting it into the air.
Take our next question.
Thank you. Just to add on that, can you give an estimate of how long the flight test program is expected to last?
Yeah, the flight program is about 1 year or so, and that's set up to look at a whole suite of different technology demonstrations that we want to accomplish during the flight test program. So, thanks.
Thank you. Our next question from here in the room.
David Curley from the Discovery Channel in Full Throttle. Mr. Pierce, can you talk a little bit about the aerodynamics and what is exciting about this for you and why you think it will work? And Mr. Citron, is this the new 737? Can you give us a little details about how many passengers, and can the technology, if it works, be scaled to larger aircraft?
Yeah, so the aerodynamics of this kind of a configuration have actually been known for a long time. If you increase the aspect ratio of a wing, you naturally lower the induced drag that airplane, the drag due to lift, right? So we know that if we do this, you get better aerodynamics, you get less drag, you burn less fuel. Those are pretty straightforward aerodynamic concepts. The challenge is, how do you build that wing? How do you get the structure to work without adding a lot of weight? Because if you add weight, then you lose the aerodynamic benefits of a configuration like that. So it took advancements in materials, advancements in structures and so forth to develop that concept. You see the brace as part of that. It's really all of that innovation in terms of being able to build a practical, very high aspect ratio wing that gets you those aerodynamic benefits is really what this is all about.
And I'll just add, certainly we think the technology is very exciting and promising. And one of the key outputs of this activity is really the learning, the knowledge of what, at the integrated airplane level, as opposed to individual piece parts of technology, at the integrated airplane level, what will the benefits be? And depending on the results of this effort, that'll dictate, as well as market conditions, whether this shows up in the next commercial product.
Thank you very much. We'll take our next question from the phones. Stephen Bridgewater with the Royal Aeronautical Society.
Hi, good morning, everybody. Steve Bridgewater from Royal Aeronautical Society in London. A three-pronged question, if I may. We talked earlier about the next generation of engines that you were planning to partner with this aircraft. Are we looking here at conventional avgas after-burning engines, or are we looking at hybrid electric and hydrogen propulsion, or is that a future project for NASA? Also, this very long truss-braced wing strikes me as going to take up quite a lot of space on stands and on aprons. Are you looking at folding this wing in any way for ground handling? And thirdly, you discussed that Boeing was by far the best candidate for this contract. Are you at liberty to say which other companies put proposals forward?
So I'll take I suppose the first and third on the first question on the propulsion and electrification and so forth. I mentioned in my talking points the Sustainable Flight National Partnership. That national partnership actually has 4 projects. One of them is associated with, or actually 2 of them are associated with the propulsion system, both increasing the thermal efficiency of turbine engines and then the hybridization of those engines. So actually adding a megawatt or a couple megawatts of electric power to the aircraft to do really interesting things. We call it mild hybrid, but to hybridize the engine so that on things like top of climb, takeoff, and so forth, you can use some of that electric power and better optimize the turbine. So we're doing those things in separate projects. Because this is technology development, it reduces our risk to take on these large technology challenges in separate projects in order to be able to manage the risk and the schedule and so forth in a way that makes the most sense. So that is all part of what we call a Sustainable Flight National Partnership. On the third question, no, I'm not at liberty to say who the competitors were for the Sustainable Flight Demonstrator. And I'll let Todd talk about the actual design. Sure.
Just relative to the first part of the question on engine technology, with that high wing, as the Senator talked about, that gives us the opportunity to explore much higher bypass ratios. So in addition to the type of fuel, as Administrator Pierce talked about, it also allows us to look at different configurations there as well. And on the second item, that is a part of the considerations. The key focus here is understanding the aerodynamics, but with the longer wing, that could involve the use of wing folds, but that's a technology that we're already utilizing commercially.
Thank you.
Thank you. Take our next question from here in the room.
Thanks. Dave Shepardson from Reuters. Can I just ask, do you think this program will accelerate the development of the 737 replacement? I mean, I think currently you're not scheduled to have a new airplane till like the middle of the next decade. Or maybe conversely, when do you think some of this technology that might come out of this program might actually be deployed in production airplanes?
Well, let's start with in order to insert technology, as was inferred by a prior question, there is a lead time. Sure. And so we really need to be working with technology today for airplanes that will show up in the next decade, and that's the intent here. Whether that happens really depends, again, on the results of this activity as well as the market conditions.
Thanks.
Thanks, Dave. Our next question will come from the phones. John Ostrar with the Air Current.
Hey, good morning. I was hoping you could talk a little more about the aircraft itself, just from the technology that's going into it. How are you, is this going to be a clean sheet nose to tail? Are you taking an existing fuselage from, I think there's been discussion of a 717 or an MD-80 to modify that? That's from a product perspective, from a process perspective, how are you thinking about the tools that Boeing has discussed in terms of model-based systems engineering and other sort of pathfinders for using this to validate the process side of this that is going to be essential for commercialization in terms of the development cost that goes into a commercial product like this?
Oh, great. So relative to the starting point, the focus of this activity is really to gain learnings about the benefits at an airplane level of this transonic truss-braced wing configuration. So in that regard, we are going to be modifying a small single-aisle aircraft to demonstrate and measure at that airplane level what the performance benefits would be.
And I just mentioned you mentioned process technology and so forth. Another one of the projects that we have under the Sustainable Flight National Partnership is a high-rate composite aircraft manufacturing project to prove out that we can economically increase the rate of production of composite components for aircraft, such as might be seen in the 2030s. Today, and probably talk more eloquently about this. It's all composite aircraft are not produced at the kind of rates you would probably see a single aisle produced at. So some of that process type technology, manufacturing type technology, is also critical to the future of aircraft manufacture and production.
Yes, and then to add,
can you talk about the sort of the actual engine you're going to use for this? Is there an X-plane designation that goes along with all this also?
On the X-plane designation, that's I'll take that one and talk about the engine that we're going to use on this demonstrator. But the Air Force owns the process for designated airplanes, and so now that we have a configuration, we need to make a decision whether we'll apply to the Air Force to have a designation. So we haven't done that yet. That's something that we'll look at in the next several months.
So relative to the engine, we're in the process across the board of finalizing our industry partners, so we'll have announcements on that at a later date. I'd just go back to the design process in addition to the materials process that Bob talked about. We will be using digital modeling and advancing our technology in that area as well.
And actually on the NASA side, we're also putting together a model-based systems engineering approach so that, like I said, we have 4 different projects. This will give us a way on our side to also look at the integrated benefits of this technology in addition to engine technology and other technologies and so forth. So we'll be able to do that, and we'll be able to sort of compare notes with our industry partners, and that'll help us, further validate the benefits of this configuration and the related technologies.
Do we have any more questions? Kristen Fisher with CNN.
Hi. Forgive me for asking a question that's a little bit off topic, but Administrator Nelson, Deputy Melroy, while I have you here, I was hoping that perhaps you could provide a slightly more specific time frame as to when you anticipate announcing the crew of Artemis II, and if you could provide some context as to how much of a role that you, both of you, really anticipate having in making that final selection process. Thank you.
The answer to your question is soon. And the answer to your second question is Pam and I and Bob Cabana stay out of the selection of the crew. That is done by the people at the Johnson Space Center. Primarily the head of flight operations, Norm Knight, in consultation with clearly the head of the astronaut office, as well as the center director, Vanessa Weish. And they will make the decision. I do not know if they have decided who the crew is, nor should we. Pam and I and Bob stay out of those decisions.
Thank you.
I want to thank you all for your time today to discuss this exciting announcement for NASA and Boeing. And to learn more about the Sustainable Flight Demonstrator project, you can visit nasa.gov/aeronautics. Thanks and have a great day.
Generation today.
Because the ambition to go has already begun.
And because Mars is calling.